Okay, so this is version 7, question 4, critical path analysis. The bits that are written here will come from your data sheet, but realistically you don't need to worry about what they are unless they refer to a specific job later on in the question. So constructing an activity network, first off, we want to have a look at what has nothing as its precedence and write those two first. So these two don't have anything, so we've got A and B. Then we're looking for things that have only got either of the things that we've already written. So B has C and D. E has C. F has D. G has E and F. H has G. I has F. J has A, H and I. And then we've got K, which just comes out from J. The purpose realistically behind doing this is purely and simply to double check that what you're about to write down will fit on your page. So we've actually constructed an activity network already, but from here we're going to draw it out properly. So stuff that we've got here, we've got A up at the top, we've got B goes into C and D, that one goes into E, that one goes into F, they both come together for G. H, J and K, and then we've got I, that would be somewhere down here and comes from F and goes in before J, and A comes in as a long one. From here we need to put in our duration, so that's the column on your question sheet. Okay, so A, these both A and B don't have anything in front of them, so they're going to start at 0. A has a duration of 6, B has a duration of 3. C has to wait for B to stop finish, so that 0 and 3 is 3, and it has a duration of 3.5. D starts at 3 when B finishes and has a duration of 3. E has 3 and 3.5, so that can't start till 6.5, has a duration of 2. D has to wait for 3 and another 3, which is 6, and has a duration of half. So G has to wait for both of these two things. This one, F, will finish at 6.5, which is useful for I to know. E will finish 6.5, 8.5. So we need to wait for both of these for G to start. So that one's going to be 8.5. G has got a duration of a half. So H can start at 9. H is 1 long. So J is going to be able to start either at 6.5 and 1, which is 7.5, or at 10, or at 6. So we need to wait for our slowest person, so that can start at 10. J has a timer of 1.5, so K can start at 11.5. K is going to take 1, so K is going to finish at 12.5. So we've done our earliest start time. We now need to do the latest finish time. So 12.5 take 1 is 11.5. Take 1.5 is 10, so that's going in there, and there, and there. 10 take 1 is 9. Okay, so these two. This one's quite simple. 9 take a half is 8.5. But this one has 2 going into it. It's given a deadline of 10 minus 1, which is 9, and 9 minus a half, which is 8.5. If it finishes at 8.5, both of these can start on time. If it finishes at 9, this one's going to be starting late. So this one's going to need to be 8.5. 8.5 take a 8.5 take a half is 8. 8.5 take 2 is 6.5. 6.5 take 3.5 is 3. So we've got our forwards pass and our backwards pass sorted. Our critical path. So that's the stuff that has to start on time. So 0 and 3 is 3. 3 and 3.5 is 6.5. 6.5 and 2 is 8.5. That bit, that bit, that bit, and that bit. So our critical path has been highlighted, but we actually need to list it as well. So we have a critical path that is B, C, E, G, H, J, K. And then we need our float times for our non-critical activities. So float, we find out by taking the first 2 numbers away from the third. So for A, we've got 10 take away 6 take away 0 is 4. For D, we've got 8 take away 3 take away 3, which is 2. For F, we've got 8.5 take away a half take away 6, which is also 2. And at I, we have 10 take away 1 take away 6.5, which is 2.5. So that's our float. In reality, in an exam, you're unlikely to be asked for all of them. You're likely to be asked for one. Then we are being asked for our Cascade Diagram or our Gantt chart, and we are looking at starts as early as possible. So starts early as possible is the most normal way of doing it. So you're looking at box at the beginning and the dotted line coming out of it. So if we look at what we've got, and if we move this way a bit, because then we've got some light, what we're looking at is basically being able to put this information into a graph. So we know it needs to go up to 12.5. So we start at 0, 1, 2, 3. Okay, the easiest and quickest way of doing this is to put your critical path along the bottom. So for that, if I go for a slightly thicker pen so it stands out a bit better. Awesome. Okay, so if we do our critical path first, we have B, starts at 0, finishes at 3. We have C, starts at 3, takes 3.5, goes up to 6.5. So the middle number tells you how long your box is. The first number tells you where it starts. Last number tells you where it finishes. E goes up to 8.5. G goes up to 9. H goes to 10. J is up to 11.5. And K goes up to 12.5. Okay, so your critical path will always fit as a line along the bottom, because if it's not critical, then there'd be gaps in it, and if it's too long to fit all in one along the bottom, then your critical path's not long enough and you've done something wrong earlier. So we've got rid of most of our diagram really quite quickly. We now need to worry about just these 4. So A starts at 0, finishes at 10, which is our last number, but our box is only 6 long. So our box only goes up to here, but our finish line is at 10. For D, it starts at 3, it finishes at 8, but our box is only 3 long. So we've got dotted lines at the end. F starts at 6, finishes at 8.5, but is only half a square long. So F goes in there, dotted line to the end. And then I starts at 6.5, is 1 long, but finishes at 10. And that is the whole of your cascade diagram done.